It is ionic bonding time, and we're looking at a quick recap of the whole topic of ionic bonding in general. So this is part one. Let's get going. Now, ionic bonding, what is it? Well, it's the type of bonding that arises when metals and non-metals react together or come together to form a compound. But what we need to do is look at what actually happens, right? So metal atoms, what they tend to do is lose electrons, right? So you definitely want to make a note of this. So metal atoms lose electrons. And why do they lose electrons? Because they want to form a full outer shell. And non-metals, what do? Well, they gain electrons in order to do the same thing, to get a full outer shell. Now, what you should note as well is that the electrons that the metals lose are the electrons that are gained by those non-metals. So let's look at an example. Let's check out what happens when sodium and chlorine come together to form an ionic compound. Now, what you should do is, sodium, you can find it in the periodic table, you look up the symbol, and the bottom number there, the atomic number, is going to tell you how many electrons it has. So we can draw that out. It's got 11 electrons. You're going to have 2 on the first shell, then 8, and then 1 on the outer shell. Next thing, let's get chlorine drawn. So you look at chlorine, chlorine's got 17, so that's going to be 2 there, then 8, and then 7 on its outer shell, okay? If you're ever stuck with knowing how many is on the outer shell, remember you can always check the group numbers. So sodium, because it's in group number 1, there it is, sodium, over there. Because it's in group number 1, it means it's got 1 electron on its outer shell. Chlorine, because it's in group number 7, has got 7 on its outer shell. Now, remember what we said. We said metal atoms lose electrons to form an outer shell. So if you look here at your sodium, sodium's got 1 electron on its outer shell. So what it wants to do is lose 1 electron, okay? It's in group number 1, it wants to lose 1 electron. So there we go. So it loses that 1 there. Now, the non-metals, what do? They gain electrons that are lost by that metal. Now, if we look at chlorine, chlorine's got 7 on its outer shell, so would be super happy if it gets 1 electron, because that can make a full outer shell of 8 electrons. Now, for ionic bonding to occur, ions need to be formed. So that's what is formed when these lose or gain electrons. So the metal atom, as we already said, loses electrons. So what's going to happen is this outer one here is going to make its way over to the chlorine. So that electron is transferred across to the chlorine. But then what forms? So when that electron escapes and goes to that chlorine, you're left with what we call a sodium ion. Okay, so a sodium ion is formed when a sodium atom loses 1 electron. So you can see that on its outer shell, it's now missing that electron and it's gone over to the chlorine. Now, sodium has lost 1 electron. Chlorine has gained 1 electron, okay, to form its ion. And so what we can do is say this. Sodium now is carrying this positive charge, and the way we show that is we've got to put a bracket around our structure here, our electronic arrangement, and then we put a plus charge on the outside. Over here for the chlorine, because that gained an electron, pop some brackets in and you put a minus charge there because it gained 1 electron. And so what do we have? We've got a positive electron, positive ion, sorry, and a negative ion. And obviously between those, they're going to attract each other. You'll have some form of attraction. And that attraction there is called your ionic bond. You would also see it referred to as electrostatic forces of attraction, right? So they love to use that phrase. Make sure you're using that phrase too if you want the marks for these kind of questions. So we've got our sodium ion here, that's positively charged, and our chloride ion here as well, which is negatively charged. And what do? Well, they form what we call an ionic lattice. So I've tried to show you a little section of it here, and then obviously a bigger bit of it over here. So that's what will happen. The ions come together and form this massive structure called an ionic lattice. There's lots of attractive forces there. And because there's lots of attractive forces there, this structure is held very, very tightly together. And therefore a lot of energy is going to be needed to break all of these forces down. And therefore ionic substances have generally quite high melting points. Now, let's look at this, where we've got magnesium and oxygen coming together to form an ionic compound. We start with drawing a magnesium atom. So that there, if you look at the symbol, it's got 12 as its atomic number, meaning it's got 12 electrons. So I've drawn that out there. We've got 2 on its inner shell, then 8, and then 2 on its outermost shell. Next thing, let's get an oxygen atom drawn. Oxygen has 8 electrons, so we've got 2 and then 6. Great stuff. Remember, metals want to lose electrons and the non-metals want to gain those electrons. And if we're looking at the magnesium, right, because it's got 2 electrons on its outer shell, it wants to lose those 2 electrons so that it's got a full second shell there. And the oxygen is going to be really happy to gain those 2 electrons because it will get a complete shell of 8 electrons. So if those 2 electrons leave, what forms? Well, we've got a magnesium ion, and that's got an empty outer shell over there. And now this one here is completely full. So that's great. The oxide ion, what happens? It gains those 2 electrons, so it's got a complete outer shell. And remember, we've got to put some charges on there to show that those are ions. So we put some brackets in. The magnesium has now got a 2+ charge. Why? Because it lost 2 electrons. So it's in group 2, lost 2 electrons, 2+. The oxide ion is now carrying a 2- charge because it gained 2 electrons. And now we've got a negative ion, positive ion. There's going to be electrostatic forces of attraction between the 2 of them, otherwise known as ionic bonds. Now then, this as well will form that giant ionic structure. And remember again, they are held together by really, really tight forces. And so it's going to take a lot of energy to break those down. This here will actually have a higher melting point than the previous example we saw. Why? Because this has a 2+ and a 2- charge. So the charges are a bit stronger. So it means that force of attraction is even greater between these 2 ions. Okay, so a higher amount of energy is needed to break them down. And that's that. So that's our part 1 on ionic bonding. Part 2 is coming, so I hope to see you in that video there.